Hello, Matthews, Gatos here. Welcome to section 6.3, solving absolute value equations. Before I get into that, I want to review what we've done with piecewise functions. So I have a linear and a quadratic example for you. Since this is a review question, please pause the video, try this question, come back and see what the solution is. So in this one here, I have a linear equation. I notice that my linear equation has a negative slope and a positive y-intercept. I see that the x-intercept is c. So I want to come up with the piecewise function. So let's look at the positive piece and the negative piece. So here is the positive piece, and that is going to stay the same. So y equals, I have a negative slope and a positive y-intercept. That will happen to the left of c, or when x is less than or equal to negative c. Let's look at, that's the positive piece. Let's look at the negative piece here. So the negative piece is going to happen to the right of c, and that will be reflected in the x-axis because the absolute value of a negative is a positive. So to show that it's been reflected, when I reflect it, the negative slope will become a positive slope, and the positive y-intercept will become a negative y-intercept. So looking at my options to see which one matches, it looks like option B matches. Let's try a quadratic one now. So again, pause the video, try the question, come back, see the solution. So in this question, we're given some general information about the quadratic, and we want to match it with its absolute value. So looking at the first one, inside the function I have an absolute value that has a negative a value, and it's in factored form, x minus b, x minus c, where b and c are both positive. Well, if x minus b, where b is positive, is the factor, then x equal to b is the x-intercept. Same thing here, x equal to c is the x-intercept. So I have two positive x-intercepts, and it's negative, meaning it opens down. Well, right away I can see this graph has two positive x-intercepts, and the x-intercepts don't change. But let's just look to see if that makes sense. So my graph is going to be something like this, two positive x-intercepts, and it opens down. So this middle piece stays the same, which I can see it does here, and the arms are reflected up, which happens here as well. So it looks like option 2 matches equation A. Let's look at equation B. So in this one here, it's in vertex form, and I can see that A and P are positive. So it's a parabola that opens up and has been shifted to the right, but Q and the y-intercept are negative. So I have a graph that opens up, it's been shifted to the right and down, so the vertex is here, somewhere in quadrant 4. I have a negative y-intercept, so to graph this, it looks like I'm going to have a positive x-intercept and also a negative x-intercept, which I see matches with this. So let's see if the rest match it. So the outside arms are positive, they stay positive, so they stay positive. This piece here that's below, the U-shaped kind of piece, will be reflected above, which is right here. So it looks like this one matches equation B. Lastly, equation C, we have this one here in general form, ax squared plus x plus c, where a and c are both negative, and the vertex is in quadrant 2. So we have a vertex in quadrant 2, the graph opens down, and c, which is the y-intercept, is also negative. So for that to happen, it looks like both of my x-intercepts have to be negative, which matches here. Okay, the U-shaped piece is positive, so it will stay positive. The two arms that are below the x-axis will be reflected above, so it looks like this does in fact match equation C. Okay, let's get into solving. So this is 7.3, solving absolute value equations. In the first video, which is this one, I'm going to talk about how to solve graphically. In the second video, I'll look at how to solve algebraically. So let's get started with what an absolute value equation is. Absolute value equation is any equation, obviously with absolute values, where the variable is inside. So see, absolute value, variable inside. Absolute value, variable inside. Absolute value, no variable inside. So this is not an absolute value equation. So those two things have to be met for it to be an absolute value equation. Let's look at how do we solve absolute value equations graphically. Now, we've done graphical solutions for quadratics, we've done them for rationals, and the method is still the same. So this first method, the intersection method, you'll remember, this method is best for checking your equation to see if it's right, and also for solving word problems. So the way that we do that is we take the equation exactly as it is. Left side goes into y1, right side goes into y2, and we find the point or points of intersection. On our calculator, we do that by doing second trace to get into the calculate menu, and then option number 5, which is intersect. Once we've done that, we state the solution, which is the x coordinates of the point or point of solutions, or of intersection, point or points of intersection. So let's try an example. This one here I'm going to solve in method 1. So I'm going to put this left side here into y1, unchanged, this side here into y2, and then see what I get on my graph. So you can see I do that for my first one, and I see that there are 2 points of intersection. So there's my first point of intersection at negative 5.5 and 8, and then I find my second point of intersection at 2.5 and 8. So I need to now put this all together on a graph. If you solve something graphically, you need a labeled graph. So I need to label my intercepts, the vertex, and any points of intersection. So you can see on my graph, I've labeled everything properly. The last thing I need to do is state my solution. So you need to state that you know what the solution is. So x can be negative 5.5 or positive 2.5. Okay, so I want you guys now to try this question here using method 1. So pause the video, do it yourself, and then come back and see the solution. So in this one here, I'm going to enter in y1, left side in y2, and right side in left side in y1, right side in y2. There we go. And then I'm going to look at my graph and label all my important parts. So you can see that's what I've done here, and I've labeled my intercepts, I've labeled the point of intersection, and now all I have to do, now that I have a labeled sketch, is to state my solution. So my final solution is that x can be 2 or x can be 3. So this is method 1, which implies there is a method 2. Let's look at that. Method 2 is the X-Intercept method. Now, this is really the method that we use for solving all equations. So method 1, good for checking and word problems. Method 2, this is how I solve every question. Every question, whether it's algebraic or graphic, I always set it equal to 0 first. Now, graphically, I'm going to find the x-intercepts. So I set my whole equation to 0, and I put that equation in y1. In y2, I put 0, which will graph the x-axis. And then we just have to find the x-coordinate of the intersection of the graph with the x-axis, which is the x-intercept. Again, on your calculator, that's second trace to get you into the calculate menu, and then option number 5. So let's try this one. So we've already solved this equation using method 1. Let's see if solving it using method 2, we get the same solution. So in method 1, we put this whole left side in y1, this right side in y2. In method number 2, we're going to set it equal to 0 by subtracting 8 from both sides. So now I'm going to put my whole equation into y1 and 0 into y2. So here's my graph. So it looks a little bit different than the one I did before, but I have the same x-intercepts. So that tells me I'm on the right track. All I have to do now is put it all together in a labeled sketch. So you can see there I've labeled my intercepts and my vertex. So all I have to do is state the solution, which is the same solution I got before, 2.5 or negative 5.5. Okay, I want you guys to try one on your own. So pause the video, do this question, and then come back and see the solution. So in this one here, our last example of solving graphically, I'm going to set it equal to 0 by subtracting x from both sides. So if I subtract x from both sides, I get absolute value of x squared minus 1 minus x equals to 0. So I'm going to put that into my calculator and draw a sketch labeling my intercepts. Now, if you want to, you could also label these little turning points, because technically that's a minimum in this area, and this one's also a minimum in this area. Or you can just kind of eyeball them to make sure that they're close to the graph. So all I have to do now is state my solution, which in this example here is negative, oh, let me try this again, sorry, positive 0.6 and 1.6. So you can see 0.6, oh, let's try that again. 0.6 is this point right here, and 1.6 is that point there. So they're really close together. So those would be my two possible solutions. So absolute value, again, to solve this, you can use method number 1 or method number 2. Absolute value, remember, is always positive. So if it were to ever donate blood, it would be impossible to have a negative blood type. It would have to be a positive. So I hope this video helped. You can move on to practice question number 1. Detailed solutions are on D2L, and then move on to your textbook questions. And I look forward to seeing you for the next one.